Hello. Hey, where's Wally? How are you? Um, I just decided to make these hangouts for tests. It is no flat earth discussions or debate, just us talking what we know and maybe correct each other. Yeah, this MLMA. Uh, Previously, my icon was a crow, uh, but I decided to put it the MLMA just to tease flat earthers. So, is there a secure place where I can put the link for you? Hello, welcome, George.
Hello there.
Uh, can you hear
I've
me?
got. Yeah, I can hear you. Are you hearing me? I'm off a different. I'm only using the internal mic on my computer right now.
5 by 5.
I'll be leaving soon. I just thought I'd come to support you here for a bit. I have to leave. It's 2:30 in the afternoon. I gotta go and take a
So,
tire into town from my skid steer to get it repaired.
so probably this is not a good time for you, or normally, or just today.
No, normally, this
Oh,
is in the middle of my business day. So
oh,
2:30 in the
okay.
afternoon. I'm usually busy from 7 in the morning till 6 at night with my business. But I pop into like Jose's and stuff because I can do hands off. I just let things play in the background. If something catches my interest, I pop in and contribute a bit, but I can't for any long stretches of time.
Yeah, that's okay. Well, I've seen there's been a long discussion in the Skype, and I didn't follow really what's going on, but I thought maybe the participants would like to talk, so I thought it's a good chance.
Right.
Well, for me, I've just finished work, so I'm not exactly up to speed with everything that's gone on today, which is always the annoying thing about being in Europe.
Well, it's going very slow here.
So whereabouts are you from, Crow?
I'm from Egypt. Oh, where's Wally? Is it 5 a.m.? Are you in Australia?
No. I'm in the UK.
No, sorry, it's where's Wally in the chat. Do you know where's Wally?
No.
Oh, come on. He's a good guy. He make some really good videos.
I haven't actually. If you post the link, I'll get the YouTube side up, and I'll be able to see the chat.
Yeah, I'll send you the YouTube link, and you can see him. So I'll put on the side chat. I'm not really familiar with this thing, so I hope I put it in the right place. Where's the chat? I don't know where's the chat.
So if on the screen you've got the little dialogue.
Yeah, the
Yeah,
blue.
yeah. Press on
Okay,
that.
okay.
That opens it up, and then just post it in enter message or link
Okay.
here.
I sent. Did it go
I
through?
got it.
So this is the YouTube. Yeah. Okay, where's Wally? I was hoping to have talk with you. Maybe I just our time for Australia too. Maybe 4 hours or 5 hours earlier than this. But then the UK folks will not be able to come in.
Yeah, I mean it's 8:30 here. I'm normally home by about 6:30. But normally, if you want to do these kind of hangouts, then it's kind of either good to sort of base it off US or European time, depending on who you want. Because the Aussies can go and jump in early morning in the US, and we can jump in sort of late evening in the US.
UK and my time is just 2 hours difference, so
Yeah,
I have no problem with UK. But the problem is I have to satisfy Australia and Australia and the USA. Whereas Wally saying I'm Wolfie Packer, Wolf Packer, sorry, with Wolfie. Wade Underworld Critical Think, and Ruhif.
Oh, okay.
Don't worry about me. Oh,
Hey,
I'd like to have him.
where's Wally? Say hi to Ruhif for me. It's been ages since we've had a chat. It's been way too long.
Yeah, and yeah. I'm also in the wolf pack.
Okay.
So there was a discussion. I've seen it on Skype about the why planes don't dip their nose down.
Yeah,
And
I don't.
Well, they do, but it's ever so slight.
yes, yes. Uh, the point is, first you have to do without the pilot and remove the autopilot and leave an airplane travel just we call it trimmed. You know, trimming the small surfaces on the control surface to keep the airplane level. And
Yeah.
if you leave the
Well,
airplane
I
like
figured it out. I mean, if you read the Skype chat, I mean, I figured it out. It's you basically say for 22 seconds of flight at flying 500 miles an hour at altitude, you're basically only having to dip your nose about the resolution of the human eye, 0.022 degrees. I
uh-huh.
mean, you're going to be correcting a lot more due to air turbulence and stuff. I mean, that's minuscule.
Yeah,
That's
Yeah,
negligible.
yes.
and the other thing as well, surely, George, is to gain altitude requires you to have more thrust. You know, to generate more lift to
Right.
gain the altitude. So if you're going with a standard amount of thrust anyway, there's going to be some self-correction done by the plane itself, or you're going to lose airspeed, I'm guessing.
Yeah, but what I'm saying is
Yeah, okay, probably
the
airspeed.
amount of correction to keep you at altitude above the surface of the Earth by having the nose slightly dipped off horizontal is going to be totally swamped out and masked by other corrections just due to changes in air density, some wind turbulence and things like that. I mean, 0.02 degrees is just so utterly insignificant. Is and plus, nobody's going to feel it because over 22 seconds of flight, you're looking at a height correction of only about 6 feet.
Mm.
That's 1/4 of the distance across the plane fuselage. I mean, you're not going to notice anything.
I mean, the one that gets me, and even just from a simple observation perspective, that I cannot understand, is not just so blindingly obvious to everybody who believes in the flat Earth. Is if I'm in the Cairngorms in Scotland, and I'm looking out and I can see a bloody long way. I wouldn't even like to guess how far I can see. But what I can see is I can see mountains in front of me and mountains behind the mountains. And I know that as I'm looking up north from the Cairngorms, it's rising in altitude. It's rising in height. The mountains are bigger as you get into the range. Yet the ones further away can seem lower than the ones in the foreground. So refraction only is a very small amount of interference on a normal day. So how am I losing so much of a mountain?
Right. Yeah.
That to me
I
just
mean,
doesn't make any
again,
sense.
Russ, what's going on here is there's next to zero critical thinking in that camp. You know.
And it's the fact they want to seem to use things like refraction to compensate for all these factors. Yet refraction is only a small variance, not a huge variance where you can be hiding 1,000 feet of mountain.
Right.
Sorry.
Where's Wally in the chat is saying that Ruhif just did the Jay Tolan SmackDown video. You should watch the one. Ruhif flew to USA to do it along the water channels in California.
I'm gonna go check it out.
I've seen that.
Well, that Tolan is just a total idiot. I mean, the first one he did where he was going across southern United States around Arizona and looking towards the Colorado mountains, he wasn't seeing the mountains. All he was seeing was some clouds. And the one mountain that he was seeing that he thought he was seen in Colorado was actually Novaha, the Novaha mountain in um, southern Utah. And I never published it. I went and I actually created a model in our park with mountains and stuff. I need to really put it together to show what he should see, and it is what he saw. And but there isn't any way he would have ever seen any mountains in Colorado at 30-some thousand feet going past Phoenix, Arizona. It was just total BS. The guy never knows what he's looking at. He doesn't know how to identify landmarks.
There's one of his videos. Uh, the curve was so clear, and he said, and that time of the video was around the time that Anthony Riley was saying at kilometer or something like that, that the lenses show curvature. So he did some critical thinking, and he flipped the camera to make sure that this is not the case. And guess what? The curve was there.
Yeah. Well, I mean, this is the nonsense we get with these people.
Yeah, I was subscribed to him because he made some a little bit challenging, at least for me, videos. But then later, I realized he just point at anything and he assume it to be something or land features. So I unsubbed. Where's Wally posted the link for the video, George?
Yeah. Well, I never watch any of his videos after seeing that one in his trip from LA to Florida or wherever he was going across southern United States. Walter Bislin and I spent an afternoon watching his video and working it out together. And I've got it all logged, just about every minute where he was on the United States and what he was seeing. And I never did complete the video. I should probably do it someday. It's a commentary basically on exactly what he was seeing, and he never ever got close to seeing any of the mountains in Colorado.
Yeah, but of course he
Somebody
says.
save me, please. Someone save me.
What's up, Stone?
Where have you been?
I've got fucking Travis, Red Hen Radio. The Plain Truth, his channel is, I think, whatever.
Oh, God.
Is asking me. He asked me loads of questions, and he is so fanatical, but in a passive aggressive kind of way sometimes. And he's asking me. So first of all, he said he disagreed with what I said on Jose's show today. And to what he was referring to would be that the sun could not light the underside of clouds. And I made an assertion. I said, if the sun on a flat Earth could light the underside of clouds, we would also be able to fly over it in an aeroplane. It is that simple.
Yep.
Now, he said, and he said, and he's asking me, oh, can you demonstrate this? And I went, well, it's like asking me to demonstrate that water is a fluid. It's like, just have a look. All the supporting evidence says water's a fluid, and there's no evidence to the contrary. So is it not just common sense?
Well, they're all picking up on this Riley quantum eraser thing. As soon as they detect they might be getting back into a corner. Citation, please. Citation, even for self-evident issues.
Well, yeah, I mean, I just linked him a study by the government relating to, and I put it in the side chat as well. It was actually.
Well, I could say, as I had dinner last night, Riley would immediately pipe up, citation, please.
Mm.
And I would turn around and said it was rather tasty.
Yeah. I mean, it is. They have taken it to such ridiculous ends and heights on this whole thing about citations. It's just laughable.
Yeah. I was once telling Riley that there is buoyancy. The science says there's something that's called buoyancy, and the equation is the density multiply the volume displaced multiply the gravity. And he said citation. So I was shocked. Did you study that at school?
But is it real? Is it really real?
Yeah, listen to this. Right. So Red Hen says to me, because he's got me on Skype, the twat. I might just delete him. But it says. It says, then he went on to rotation. Right. So first of all, it said the problem is this: we have observations and we live on a plane. So your claim is false on its face. The observation is possible on a plane because we're on a plane. Every observation claimed impossible on a plane fails in the same manner. We don't feel spin. And I said, we detect spin, but it's too slow for us to. We can detect spin, but it's too slow for us to feel it. And no, all observations do not support a plane. Ranty photographs and video prove the curve on a daily basis. Everyone else is just capturing massive refraction, not something that should be done when attempting to figure out geometry. Now, the things we do observe are impossible on a flat Earth. Star trails, angular size of moon and sun, which match the heliocentric model exactly. Sunrise and sunset, eclipses, orientation at the moon at the same point from two locations. All of these destroy flat Earth, but it's okay because you photograph something just right in a glass of water and everything else is upside down. Awesome. Makes sense to me, my friend. And then I put, think of it this.
Invite me into this conversation. It sounds fun.
Yeah, he said. I said, think of it this way: there is no falsifications of the heliocentric model, and there is no flat Earth model that can work in any aspect. That should say something, or at least it should at least get you thinking about a bit why. And he said, "Awesome, another claim. Please prove that. Please prove at what scale our ability to detect motion fails." And it's like, what? And I put, I don't know, but it would need to be more than 1 degree per minute. But obviously, I needed a velocity, and I think it's 0.03 meters per second. Is that in George? George, is that in it in acceleration?
The angular velocity of the Earth is 0.004 degrees per second.
No, but that's a turn rate. I'm on about an actual acceleration of motion from point A to point B, regardless of.
Well, it's zero because we're
Well, the
relative to the
thing
motion.
is,
No, it isn't.
We don't accelerate at all.
Dean,
No, change in motion. I mean,
Dean, the best way to describe the motion of the Earth rotating, or as they would say, the spinning ball, is it basically works out to the centrifugal force.
yeah, and I put
Or
0.03 meters per second.
It's 1/291th of the acceleration due to gravity. Or just say that the acceleration that you feel that's going to try to throw you off the Earth.
Yeah, what is it? It's one.
What is
it's about 2.63 newtons.
With you guys continually interrupting me on this.
Yeah.
It's maddening.
I just want to point out, George. I just want to point out, George. I'm not interrupting you.
Well, wait till I'm through here. It's just only going to take 30 seconds.
Yeah, I just want to point out, George. I'm not interrupting you.
Yeah, right.
I purposefully tried talking over everybody then.
Yeah, the centripetal acceleration, or the force that you're going to feel trying to throw you off the Earth, is 1/300th of your weight. So if you're a 150-pound man, that acceleration, that force will be 1/300th, or about a half a pound, 8 ounces. Now, but that's constant. That doesn't change. The rotational velocity of the Earth is constant. So
that's false, though. That was false, wasn't it, George? I wanted.
What's false?
I said force. Sorry, I've got a tooth broken.
Yeah, the force. It's directly related. It's either acceleration or force. It's just they're proportional to one another through one's mass. So you can talk about force as equivalently as talking about acceleration. So the force that's going to try to pull you off the Earth for a 150-pound man is 1/300th of your weight, or about a half a pound force. But
What's
that's
a
a
pound?
constant force. That doesn't change because the rotational velocity of the Earth
About
is
460 grams.
Is it? Yeah, these Americans and their fucking silly units.
Yeah, well, the conversion is an ounce is
2.21.
28.35 grams.
Yeah, I wanted an actual motion, so it works out as 0.032 meters per second change.
Square.
Then, yeah, per second. Yeah, no, that's cool. I was kind of correct when I said 0.03. I think then.
Well, it's always better instead of people's eyes gloss over and they stop listening when you start putting small decimal numbers. Just say, you know, the force that's trying to pull you off the Earth, the centrifugal force, is basically 1/300th of your weight. Of any object.
291. I got it
291.
from,
It's
yeah,
291, but I'm
yeah,
saying
from your
you
lecture.
can
Yes,
approximate it with
yeah,
1/300. It's easy to remember 1/300, but
Yeah,
in my
exactly.
video, I figured it out to be 1/291.
I remember this number because this is what was in your lecture.
Yeah. So I'm just rounding it to 300. From 291. It's 300 is an easy number to work with.
300 Spartan, so we can remember it this way.
Yeah. So basically, and that's constant. That's a constant counter force acting on your body. So you're never going to notice it. It's as if the Earth isn't spinning, you just reduce your weight by 1/300. You're never going to.
You add to your weight if it wasn't spinning.
Yes, yes, exactly. Yeah, because of the spinning, our weight is reduced by about 1/300 of what it would be if the Earth was motionless.
Mm-hmm. No, that's cool.
And
That's
that's
cool.
on the
I am
equator.
on the right track thinking about this. So yeah. Yeah, that's a maximum effect on the equator, isn't it? So
Yes, and it gets considerably less as you move towards the poles. That's the maximum decrease in your weight due to the centrifugal force. And it goes as the cosine of the latitude angle. So
is that why Eskimos are shorter?
Is that what?
Is that why Eskimos are shorter?
I didn't get that.
Is that why Eskimos are shorter?
Oh, okay.
Well, yeah, there you go. I never thought about that. And the pygmies, too, in the southern hemisphere.
Wouldn't it be crazy if you made a joke that was actually factually accurate and had statistics to back it up, but we just didn't know?
That would be doubly funny.
I have a good question. I have a good question, please. We know why the Earth is oblate spheroid because of the rotation, right?
Yeah, there's a bulge at the equator by 22 kilometers.
Yes, this makes sense and completely explainable. But the other thing, what do you call it? Pear shape. Why?
Oh, forget that. That was an exaggeration. That was kind of a joke.
Just really quickly though, can we not? Is this not a proper assertion to make? The planet is about as round as a snooker ball.
Yeah. Well,
the variances in a snooker ball are more than the Earth.
Well, it would be impossible to draw on a sheet of paper the distortion that the Earth is from a perfect sphere or circle cross section.
Yeah, because when you start pulling out pair and oblate spheroids,
the width of your pen or your pencil would totally swamp out any deviation.
Yeah, but I wasn't interested in having some knowledge for a debate. I was asking why.
Well, this whole thing that Neil deGrasse Tyson, what they take the quote out of context, because if they had listened just a minute longer, where he qualified what he meant about the Earth being pear-shaped, is that the bulge about the equator is not symmetric. It's a little more bulge to the south of the equator than it is to the north of the equator, hence more of a shape of a pear. But, it's an unfortunate choice of words that he used because it's far from being pear-shaped. All he was using is that it's a little fatter below the equator than above the equator, and
Yes, I want to
hence
know why.
pear-shapedness.
Even if it's 500 meters only, I want to know why these 500 meters.
I think it's probably due to land mass and ice distribution on the planet Earth, would be my guess, but I'm guessing.
Well, that would be the opposite because the land mass
Wait
is
a minute. Ask me that
concentrated.
question.
No, it wouldn't. No, it
What's that
wouldn't.
question
Not if you're
again?
looking
What's that
at
question
the
again?
surface.
I
Not
missed
if
it.
you're looking at the surface of the ocean, because the northern hemisphere is land heavy compared to the southern hemisphere. Most of the water,
What was the
ocean, is
question?
in the southern hemisphere.
Why is it a bit more bulgy down south than it is up north?
Right.
That's
So
correct.
yeah, but it's so insignificant that it doesn't really matter. However, a very interesting thing on this is oh god, I can't believe I'm going to say this. Incorrectly assumed that the face of the moon is lacking the amount of craters that the ass end and the sides have. The face that's locked to us because of it's protected by a geometric comb, and the gravitational forces from the Earth make less of a probability of asteroids hitting it from the face that we see. But the interesting thing about this is that's not true, or it's not true in the way that science accepts it, and it was more to do with the formation at the point of it cooling that determined not only its shape and the fact that it's locked, but also the topology and surface makeup to how much it would be affected by meteor hits as well.
Well,
So
some of what you said is not true.
what's not true?
The locking of the surface of the moon to the Earth had nothing to do with its formation.
Oh, did it not?
No.
Why? What does that then?
Well, it took millions of years for the moon to get tidally locked to the Earth.
Yeah, well, that doesn't match the Wikipedia article then, because when they say it's about the actual surface topology and the granularity of the materials on it, they mentioned while it was cooling after formation. So if it was still rotating at that point, okay, I'm inferring that it was semi-locked at that point, but then the Wikipedia article
No,
doesn't make
no,
sense.
no, 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 no. You have to look at your time scales on this to become for planetary systems to become tidally locked takes hundreds of millions, if not billions of years. The Earth is becoming tidally locked to the sun, but that's not going to occur for hundreds of millions to billions of years from now.
But
It's a
I think
very, very slow process.
I think what Dane said, why there's more crater in the opposite side,
Yes, but
makes
I'm
kind of
saying
sense.
but he was saying in the same breath that the Earth during the moon's formation, it had become tidally locked, and that's not true.
Yeah, but then I don't get that Wikipedia article that I read then, because it infers, surely there's no other way to interpret this. It infers that it must have been, otherwise, what's the relevance of a side of it being a different temperature and solidity at any point in time? I don't get it.
Wait, you're talking about the craters, right?
Yeah, so
So
if
that
you
has nothing to do with the formation. I mean, oh, maybe it does, but it
No, no,
doesn't
no,
have
no.
to.
What it is the Wikipedia article states that on its formation, that during the cooling, the surface topology and density of the surface was affected, which is why one side shows more asteroid collisions. That's the thing that's confusing me at the moment.
It doesn't have to be hot to have
What's the
craters.
article? I mean, not all Wikipedia articles are correct. I mean, it takes a long time for a Wikipedia article to be factually correct, you have many authors reviewing it. I mean, I've participated in writing Wikipedia articles after the fact to help the authors correct some of the statements. So I'd like to see the Wikipedia article.
I shall find it.
They aren't all necessarily 100% correct at this point in time. It just depends upon how many people read it and participated into massaging the page to make it factually correct. If someone all of a sudden starts a new wiki page, he may have some misunderstandings, and it takes, it's an evolution of participation to ensure that a wiki page is accurate. They aren't always 100% accurate out of the chute.
Maybe.
But if there's asteroids right now, wouldn't it make the same shape of craters? Or does the moon has to be molten hot? Hello?
Yeah, no, I don't. I think it was. It's not about the temperature when the craters hit. It was about a bias at one side. From the Wikipedia article, I read this yesterday when I was having an argument with Rumpus.
Well, if the moon on the far side in relation to the asteroid and the Earth is in the middle, I think the Earth gravity would pull it down to it. And if the moon is between the Earth and the sun, and between the Earth and the asteroid wanting to go to the highest gravity may collide or drift to the moon. So that's why I said it makes a little bit of sense.
I'm going to show you. I'm going to share with you the thing that I showed Rumpus. To support my argument, give me a second. Right, so we'll have these as spheres. We'll have them red. There we go. So, yeah. So my assertion, Khaled, was this. Given the fact that we can see one side of the moon and it appears to have a lot less craters than the other side, my assertion was that given two gravity wells and a geometry occlusion factor by the nature that from one side the Earth is going to be protecting it, by all these factors, the probability of the face that is facing us being hit decreases. And the way that I wanted to demonstrate that is I've got this orbit here, which assumes asteroids coming in, and they're all directed at the moon. Yeah.
Okay.
So it's given this fact. In fact, let me just do this so I can show you. So it's given this fact how many of them will hit. And if I go like this, we can see that they're all coming in. They're all coming in. Boom. Except 3 got blocked by the Earth, but it's almost insignificant. Yeah. So we can see.
Whoa! Wait, how did you make the move?
No. Anyway, I'm just good. I'm good like that. I'm making them collide as well, and all sorts of stuff. Now, are you ready? Now, so just based on an object being here, it's already deflected 3. Now, my assertion was that when this has a magnitude of gravity, this body here, that more than 3 will miss, given the same input parameters. So now we see this. So this is with gravity playing a part on the Earth. Now, the amazing thing here is we actually see that the pattern that starts forming is about what we see on the moon. We can see now that there is a gap.
Yes.
So it was my assertion that the probability of asteroids hitting the front face of the moon due to the Earth is decreased, no matter how small. I still stand by it, but I'm in an argument with Rumpus at the moment. But I'm going to make a better simulation that deals with a lot more
Well,
of
of
this.
course, my argument that I used on this, Dean, is even if, say, over a period of 100 million years, if the presence of the Earth um, causes just one less asteroid to hit the face that's hitting the Earth, say, in a period of 10 years, just one in 10 years,
Mm.
less on the front face over 100 million years, you're looking at 10 million more hits on the backside than the front side.
Yeah, yeah, yeah.
Can you make that simulation that from other two sides, from the moon side and from the Earth side,
I
with a
don't.
little bit of shift?
I don't understand. What do you mean, Khaled?
Like they're coming from the left, the way you.
Well, no,
Or,
they're coming. I transmit them
yes.
rotationally from
Okay.
this ring,
Okay.
and each one of these is aimed at the moon.
Well, they come from the top. Can you make them from the left and from
Oh
the
no,
right?
this is well, this is left. This is
No.
this is the ecliptic plane, and Y this is up to me. Yeah.
Yeah. Just keep the same orientation for a moment.
Mm-hmm.
Okay. Can you orient it a little bit to the right?
I'm still not following you.
Just rotate the whole plan to the right. Have the moon behind the Earth.
Oh, you mean like this? What you mean the view?
Yes, the view. Yeah, okay. Let us see the moon. Just go up a little bit. All right. So now I see the asteroid are coming from the left side.
Mm-hmm.
Can you make them coming from our side or the opposite side, the far side?
Well, this goes around and shoots asteroids from a ring. This ring, so it's doing them from 360 degrees.
Oh.
Each one
Okay.
of these asteroids is aimed at the moon, the center of the moon.
But this should be aimed more at the Earth because the Earth is the higher gravity.
No. So this was to test the probability that if I have n number of asteroids all heading straight for the moon, does the Earth make
Oh,
any of
okay.
them miss? And if it makes them miss, what happens? And I see that this starts to form. There isn't an asteroid here in the middle of the moon that's been hit.
Mm-hmm.
And that this is my premise. This was my assertion. And I still think I've got it. I just need to. What I'm going to do is I'm going to emit asteroids randomly, given a volume in every direction, and then just have these two gravity wells to show what kind of what kind of stuff they come up with.
But I think
You will not have arrived on this until you get me a sworn statement from Rumpus that says I was wrong.
he'll never say that, even if no, I would say that he's wrong actually, wouldn't I? Yeah.
Or how about that? Rather than being so harsh as saying I am wrong, I was wrong. How about just I was mistaken?
Yeah. Yeah, but this was the this was the test that I was doing, and like I say, what I'm going to do is I'm going to have a huge volume, or that where I'm going to generate loads of particles in different, loads of asteroids, meteors in different directions, and then turn off the gravity and the Earth and see the pattern that would hit the moon, of which we would expect. Then put the Earth back in, and see if that changes. And then I'll have simulated it, because these are actually simulating two gravity wells. So.
but I think to be fair for this test, you have to make those asteroids going to the center point of the gravitational pull of the moon and the Earth together, which is like 4,000 kilometers from the center of the Earth
Oh
towards
yeah,
the
no,
moon.
no, no. Obviously, I've changed scale to visualize it a little bit here. But both of these have gravitational, wells. So, for instance, if I were to, I'm generating two gravitational wells. So if I move those wells out here, the simulation looks a little bit different now because they're going to not even make it to the points.
Some particles changed their mind. What is this? They were going to the Earth and the moon, and then they changed their mind. And
Yeah, no, I've moved the gravitational
oh,
wells to the
okay.
side to show you what the gravitational wells are doing. These two things. So this one has a magnitude of 5. This one has a magnitude of 4, but it would be more like 2, I guess. And this one will be a magnitude of 6.
Okay, but your aim is the moon, right?
Yeah.
Okay, now keep the gravitation wells as they are, but when the asteroids are coming from a very far distance, they cannot distinguish between the moon and the Earth. They are coming to them, both of them.
Oh yeah, no, I know that. I know that. But what I'm going to have is I'm going to have them firing. I'm going to generate a sphere. That inside this sphere, I'm going to generate lots of random directions, so
Can
that
your
then.
computer do that?
Oh yeah, yeah. You see,
Really?
yeah, yeah. You see, wait a minute. You see, wait a minute. Where are we? Oh no, you can't see this. But I was going to show you my 24 simultaneous threads that can be running on my Xeon processor. Could do quite a lot. So yeah, I can absolutely do that. I will win this with Rumpus. Yeah, don't worry.
Did you see? I think I'm not sure if it's Mick West or Water Bislin. He made a gas simulation, how gas particles fall down on a planet and then create atmosphere.
No.
It's beautiful. Uh, I'll try to find the link. And what I wanted to do with this, it has a lot of options that you can change. Even you can change the gravity or to remove the gravity of that planet. So what I did is just to spread all the gas molecules randomly and leave them
That would
to
probably be
attract.
that would probably be Walter Bislin. He has a lot of little simulators like that with adjustment bars that you can change parameters.
Yeah. Okay. So yeah, maybe it's him. I wanted to see if those air gas particles will accumulate and then something to simulate the creation of stars.
Hmm.
But I couldn't make it because at one time there's a what do you call it, rhetoric, rhetoric or literature. A phrase came to my mind. um in the beginning there was gases and gravity said let there be stars.
Hmm.
So it actually what created the vacuum of space is gravity. It's not the other way around. How can gravity defy the vacuum of space? No, it's the gravity that created the vacuum of space.
Yeah, by pulling all the matter away. Have you seen my water simulation, Kenneth?
No, not sure. Can you show it here?
Yeah, let's have a look. So I've just put a foam on top of it. So can you see my screen at the moment?
I'm presenting you. Yeah.
Yeah, so this is my water surface,
Mm-hmm.
and it's got foam on it. And if I turn off the render, you can see the geometry here.
Yeah.
But if I play it and make sure that it plays every frame, you can see that it is actually a proper water simulation.
It's beautiful. A couple of years ago, I went to an engineering office. They make these things. They use a, I think, application called. I forgot what it's called.
Real flow.
No, it was something else.
I would say
It's
Real Flow does very good water simulations.
yeah, and it cost me 200 in Egyptian pounds to 2,500. That's like $150 maybe.
Right. Wow.
Yeah, because I was thinking about some crazy shit, and of course it doesn't work. I was trying to to measure the forces in some kind of tubes that when the water run or pumped in these tubes, they will result in centrifugal force in one direction more than the other.
Mm. Here's an interesting thing. You know the simulation that's running here.
Yeah.
The input parameters that I have for it are really cool. They're incredibly simple as well. I have gravity, ocean depth, wind speed, and wind fetch distance.
What is wind fetch?
It's the lateral distance that wind travels over in a coherent manner. So if the fetch distance is tiny, then you have very turbulent wind. If it's very long, then you have a big storm front kind of thing. These are things that, yeah, in nautical terms, I think there's charts for them, and it's actually built off weather charts. So these are real world variables that are used. They're not something that like this program made up. But like the wind speed here, I've just turned the caching off. If I up the wind speed to, let's say, 10 meters per second, it becomes a hell of a lot more turbulent. So now we've got a little bit more turbulent waters on it. If I up it to
What's
20,
the height of the waves at this moment now?
I don't know, because these are big swells that are going on here at the moment.
Do
Because
you have a readout?
no, this area
No.
here is actually a window into a simulation. So the
Yeah.
simulation data is throughout this scene. This geometry here is actually a window into the simulation, because if I move the geometry around, the simulation is constant. It's not actually deforming the geometry. The geometry is actually
Yeah.
looking into the simulation.
Like you're looking at a portion of the
Yeah.
ocean.
Yes, because if I scaled it up, we see more of it, but it gets less detailed, obviously. Or scale it down, we'll get a lot more detail. But I could dynamically vary this as well. But I'm going to use this as examples when people are talking about wave height making a difference to observations. Great. What wave height do you want?
Yeah.
Because I can
Uh-huh.
have any wave height you want. What difference do you think it's going to make?
I have a question. I'm not sure if your simulation can answer it. If we put pressure sensors all over this area
Over
at
what
the,
area?
of the ocean in that window
All right.
at
Yeah.
the at the bottom of the ocean,
Hmm.
are they going to read different reading?
Oh, different pressure densities. I think the variance would be minute. It depends on the depth of the water. Obviously, the pressure variance would depend on the depth of the water. That water simulation that you saw there had a height of 1,000 meters.
Oh,
So my answer there, if you planted them at the bottom, would be no. There'd be no difference whatsoever. But at 5 meters, I'd say yeah, quite a big variance. And I don't know what the the relationship or equations would be that determine that. But yeah, the shallower, the more the pressure change would be greater, or the pressure differential between peak and trough due to motion and compression would be a lot more.
that's intuitive, but is it true?
I think
I've been always asking myself this question.
um, I think so, because when I've been out swimming or snorkeling, and it doesn't have to be a cresting wave, it just has to be a wave with a significant peak and trough. comes over me and I'm in shallow water, I can actually feel the pressure.
Uh-huh. Yeah.
I've definitely felt the pressure on that, because you can feel it in your eyes most of all, to be honest. Not when you're wearing a mask, you can feel it in your eyes. You know,
Well, the thing to do is waves have mass. So there'll be a tremendous force. A wave has a lot of energy. So if you're being hit by a wave, you're obviously, that wave is imparting a lot of force and energy towards you.
George, do you know Tim Cook, the Apple CEO?
Well, I know of him.
Sometimes you're a little bit older than Tim Cook, but your accent sounds incredibly like Tim Cook sometimes, and how you pronounce words.
Could be. I don't know where part of the country he's from. I mean, people say I have an accent, so it tends to be a northern Minnesota accent, because
Give me a minute.
I'm real close to the Canadian border, and so there's a little bit of that in northern Minnesota lingo, I guess you'd say.
Mm.
Except I haven't quite have the A. I never say A, like the Canadians A.
Is that a thing, or is that just a typecasting?
No, that is the thing. You go across the border with, a mile from me, and you hear A's all over the place. A.
I'm back. Sorry.
The Canadians often conclude their sentences with an A.
Hello.
Yes.
Yeah. Sorry. Different subject. If you're done with what you were talking about, did
Yeah.
you see the movie? I think it's called Hacksaw Ridge or Hacksaw Ridge.
Yeah. Yeah. War movie. Hamburger
Yeah,
Hill and Hacksaw Ridge. Yeah.
Hacksaw Ridge. Yeah, yeah. So it's someone who saved how many lives? 70, something like that.
I don't recall the details of the movie. I never really focused much on it.
Well, he was, I think, a priest. I'm not sure if he was or not, but he was a religious person, and he wanted to serve his country, joining the army, but he didn't want to kill anyone. And so there was that situation where he saved the several, like something between 50 and 90. I'm not sure. So when I see something like this, so it's just very touching, and tells people that religion is not necessarily a bad thing.
No, I never claimed it was a bad thing. I just not into it.
Statistically, I will claim that religion is a bad thing. I'm really sorry. I just
No,
will.
people are
There are
bad.
there's certain aspects to it, but yeah, most of the bloodiest wars that humankind has been involved with have been, under the guise of religious crusades.
Mm.
Yeah, who's that person that say guns don't kill people, people kill people. So same goes
No,
for
no, no.
religion.
They just don't know physics. It's the bullets that kill people. Blood loss kills
Oh,
people,
okay,
inflicted by
okay.
bullets, but that originates at the gun. Um, but no, I actually believe that promoting belief in something without good reason to believe is not good, and it doesn't matter. Doesn't matter what nice feelings you get from that. If there's no good reason to believe, then I think that's wrong. And I think people who require religion to be good, that's worrying. That's incredibly worrying to me.
I will not disagree with that.
That's about the best endorsement that you'll ever get from George.
I was once in that Hangout, that 24/7 Hangouts. You always get spammed by it, I guess. We all do. So they were so cool. You know, most of the panel was flat earthers, but they are just relaxed and they let you talk. So it came up.
24/7 will let you talk? Are you kidding me?
Yeah, in my experience,
No,
I
oh
went there
no.
once or twice.
The minute I go on there and they saw it was me, they immediately banned me.
Maybe because I don't know, maybe because I'm someone unknown to them, so they wanted to know what I'm going to say. So came the issue of science versus religion, and I said this: the fault or um, the guilt falls on religious people. They cause the gap between religion and science. And I'll take, for example, the mind of God. The way they insists that things should be the same way as we read it. We read this is true. What anything else is not true. So when they go to school and they go to college, or some of them, and they find by themselves that there's evidence, undeniable evidence, that what they learn in the Bible is wrong, they just drop it. That's why we get people who used to be Christians, and then they stopped, they left the whole thing. And guess what? They agreed.
So Dean left.
I think so.
Yeah. I'm just trying to finish up some things. If there's something you want to say or whatever, I'm going to be
Yeah.
pretty quiet here while I finish up my document.
I think I'll go too, but I'll check a link was sent to me by Where's Wally. I think it's the link to that gas simulation. Yeah, it's from Metabunk. No, that's the video, and yeah, simulation. I'll send you. I'll put the link in the side chat. Thank you, Wally. All right, I think I'll go now. There's Egypt and Congo is playing football. My wife and the kids are there watching in the stadium, so I'll go follow up. George?
Yes, I heard you. Take care.
Yeah, okay. Thank you. Bye-bye.
See you later.